Hello everyone, today I'm going to be showing you a program I wrote in LabVIEW for AP Chemistry. This is for the electron configuration. So basically what this program does is that it works for atomic numbers 1 through 112. So if you enter any atomic number, like let's say for hydrogen, so the first one, right, and then you just type in the number of electrons right here and you press run. So this gives you the electron configuration. So it's going to be 1s1. These numbers over here are the numbers that will actually show up when you will actually change when you type in like different numbers of electrons. So if I type in 100, it's gonna a whole bunch of these are going to change, and you will know that if you've studied the electron configuration rules. So that's basically how I got it arranged. This can help you I guess like do problems quickly, or if you want to know just the electron configuration of elements just quickly. This is a very efficient way to check. So this only works for the elements that follow the rules. I have not included the elements that break the rules currently, but if you want to, let's take a look at the program. So basically it runs with 4 different types of sub-VIs. Each sub-VI is for a different orbital. So this is a sub-VI for the s orbital, it's a sub-VI for the p, d, and f. So if I open one of these up and then go to the block diagram, so this is the actual code I'm running. So I take in the number of electrons, I compare it if it's so this is for the d orbital, and if it's okay, so if it's greater than 10, then it's gonna show 10, or if it's not greater than 10 and it makes it to this step, then it's gonna give it's just gonna return the number to the suborbital value. So if it was like 9 left at this stage, so it's not greater than 10, right? So it's gonna go to false because this is a boolean. This so it'll be false, and then it'll just go to the suborbital value. And what this actually does is whatever is passed on to the suborbital value, it subtracts it from the number of electrons. So now you have something that I call the pass-on value, and that's actually how this program generally works. If you've noticed, every one of these actually has a pass-on value. So as your number of electrons remaining decreases, it's going to pass that value on, and only then it'll keep on going. So as you can see in this last example, we did not make it to the final 60 layer. So anyways, I'm going to have this program, the folder for this file and all the sub-VIs, these 4 sub-VIs, all in one folder for you guys to download and use. And I'm probably going to be improving this program. Oh, one last thing is that this initial step, so I basically said you have to enter a number that's greater than 0 and that's less than or equal to 112. Should change this comment right here. So right here, if I entered 0, you're gonna see that, and I run the program, it's gonna say tell me to use a number between 1 and 112. Okay, and then when I enter something that is valid, like 5, I get over here message for user valid, and then it actually computes it. So that's basically the gist of this program. I am gonna have everything in one folder available for you guys to download and try out if you'd like. Yeah, please let me know what kind of improvements you want, and